Welcome to Information Technology Security. This is foundational to information technology itself. Security. It's a big issue today when it comes to doing business. And of course, it's very big with governments and military and other institutional concerns, such as, say, in hospitals with medicine and HIPAA requirements, the security of data itself. So we're going to be talking about this issue in this section and try to look at it from several different angles, but especially business itself. And in the sense of really corporate espionage, which is maybe sounds like a fantastic way to refer to it, but really, and bottom line, corporate espionage is at an all-time high. And even hacking itself is at an all-time high, with hackers trying to influence and make doing business very difficult in certain areas of say across the internet or with the products and services that they're providing. We're going to have to look, of course, at the need for controls. You have to have security controls for employees and other users for the safety and integrity of the data that's being handled or shared. It is essential to understand what these controls are and how they function in terms of security and the way in which we need to manage logging on and being on a network and a part of a network and using the information and data or the assets that are available once you're on the network, say with servers and files and folders and so forth, that you can have access to once you're on the network. So we're going to look at those types of things, what we call information system controls, firewalls, and something called IDSs, and what it means to do auditing. And also we'll talk just a little bit about cryptography and encryption. Why do we need these controls? It's obvious. The biggest danger we have to the loss of information or the compromise of information comes from inside the company, comes from inside the institution, comes from inside the government, military, etc. That's where the weakest or most vulnerable link often is. It can be a disgruntled employee. It can be someone that's been developed to wait for long periods of time before they actually go into action and start compromising systems and gaining access to information that's very sensitive and confidential. As a manager, you're going to be responsible for the control of the quality and performance of information systems at your business. And like any other vital business asset, the resources of information systems, the hardware, the software, the networks, and the data, they all need to be protected. And only those people who need to have access to certain resources or assets should have the permissions or the privileges to do so. The computers have numerous ways in which they can be controlled, and today we've got much more sophisticated ways to control entry onto a network as well as gaining access to resources than we had in previous years. We certainly have password protection, but we can have fingerprint ID and biometric ID where we're using iris, biomedical iris identification by scanning your iris in your eye, and there you've got something just as unique and precious as a fingerprint. You can also have voice print identification, You can have physical access where you have to have a card to scan to even get entrance into a room, a secure room. There are ways to take out confidential hard drives, just to take them out of the computers and then lock them up into certain rooms at the end of the day to keep a person from taking them out of their machine and then just walking out of the building with it. There's uh, other ways to do this, a series of passwords, something known as a password generator, something that would generate a random number that you have to attach, let's say, to your password or your user ID within a certain amount of time, and then you're able to um, to gain access because you put in that number, and that number was randomly generated by a server, so that you can uh, be the person that has that number. For example, this is one here that I have, and I'll try to put it up close to the camera, and you can see a number that's on this key. That's actually a key that is generated, and it is part of a server software system that has been created by RSA. And you've probably seen these kinds of things before. So they have these mechanisms in place, and of course, all it is to make sure that the individual who is using the machine or getting on the network belongs to get on it, and also that they belong to get access to the data or the resource that they're trying to get access to. Effective controls are needed to ensure security, and also has to do with the accuracy, integrity, and safety of the information too. You want to make sure that the control that you use can minimize errors, mistakes, or changes in data that should not have occurred in the first place. It's very important. You can have like a quality assurance about how people handle information and how it is populated to databases, and how people can check its integrity too, can come behind someone else and check the integrity of the information as it's being stored or as it's being um, moved from place to place within the system. This has a positive effect on people when they know they can depend on that, say with banking or with changing their address or their phone number or anything to do even with healthcare information, where it's very important that the information be accurate and current and up to date, and it sure should be seen by the right people too, not by just anybody that has access to healthcare information. It should be people that are healthcare professionals. So all of this is designed to focus on ways to control the handling and transfer of information, how data is entered, how it is updated, how it is checked for accuracy, how people are at different levels, have different levels of access and authority over information. All this is very crucial in terms of what we do with information today. We have malfunctions. We got hardware controls too, not just people controls, not just the way we control data entry. We have the possibility that our electrical devices can malfunction, that the circuitry can fail, that we may not have enough redundancy in them too. Can they bounce back? Then can they handle interruption? Can they handle failing? What happens if a hard drive fails? can you take the hard drive out, replace it with a new hard drive, and then the new hard drive, will it be able to uh, get itself set up like the former hard drive was that failed? In other words, will it be able to reduplicate what was on the other hard drive, and how can it do that? Do we have systems in place for redundancy? And it's also called fault tolerance. They're very similar ideas. How fault tolerant are our systems to break down and malfunctioning? We have special purpose mechanisms built into them too, in microprocessors and associated circuitry that kind of back up pieces. We have, not just a loss of power here. We're talking about inside the machine. If you lose power, then you should have power sources that come on and back up your loss of power. Well, it's the same thing here. What if some of your components fail? You have components that will take over in other parts of the system so that you can continue to operate and continue to process information. This is really important in a data center, for example, when there's failure or it's equipment. If the air conditioning goes off for any length of time in a data center, it can affect all of those components very, very quickly. So they have to have backup and fault tolerance and redundancy when it comes to the cooling systems in a data center. So you've got software controls too. So you not only just have hardware controls, you have software controls that are going to be able to handle things when software, say, stops functioning and runs out of memory, or has a problem outputting the information so that the data doesn't get lost somehow. How can we control the quality of the information and products produced by an information system without the output controls? Because that's what we're really looking to have, is that we want this output, we want these results, we want this information that's going to come on the other side. And if we can't control that, then we don't have very much. We have storage control too. How can we protect our data resources? We don't want that to be so sensitive and so vulnerable that we can easily lose it. We've got it stored, we've got it in a protective environment. If we ever need to go get it, we can go get it. But again, here we're talking about libraries of data. We're talking about large amounts of data. And how do we control it, manage it, keep it, and keep it safe, so that if something changes in the environment, or we have physical things like electrical spikes or something to do with changes in temperature, humidity, whatever, how can we make sure that our data that's stored won't be lost or corrupted? We can't have too much magnetism around sometimes. We can't allow unauthorized access to stored data, because when that happens, sometimes they can erase something or steal something and it's no longer there. Well, again, we're looking at all kinds of things that have to do with maintaining the environment. This could be physical, this could be the facility itself, just driving in to the property, that sort of thing, as well as getting inside the building. And then once you're in the building, being able to have access to other parts of the building. And then once you're on the network, how are you then verified and authenticated as an authorized user? We have encryption and firewalls too. I showed you the little key distribution device that I just had with RSA. FITITSecurity, that's the name of the company. What you also have too is thing to do with the ability to encrypt data. Now, this is a serious kind of thing too, because you want to be able to encrypt your data, but you also want to be able to decrypt your data. And so you have encryption standards that you can use, and there are different forms of encryption standards that you can use based on different algorithms. And this is a huge subject. It's highly mathematical. But there are cryptographic encryption systems that are used to protect data too. And it's very time sensitive is what it is. Some encryption standards are able to encrypt your data in such a way that it would just take an enormous amount of time to decrypt it. And then on top of that, you have to have the right processing systems to do that with. You have to have the right computer systems to even be able to process that, to make that happen. So there are many of them. There's DES, DES, Data Encryption Standard, and triple DES. You usually see a 3, and then DES, again capitalized, and that's triple DES, Data Encryption Standard. There's AES, American Encryption Standard. There is the RSA algorithm, and the letters RSA are the first letters and the last names of the people who, mathematicians who came together to create that encryption standard. There's PKI, public key infrastructure, and there's the MD5 hash that is used for hashing purposes, and there's SHA. There's SHA-1 and SHA-2. And you can really, if you'd like to find out, this is a really big area, fascinating area. If you want to find out more about this, then you should Google it. You should go on the internet and look at all of these encryption standards and what they do to protect information. And finally, we need to just mention about firewalls and IDSs. Firewalls are both, can be a physical device, and they can also just simply be software. Some of your operating systems like Windows comes with its own firewall now. I think it's called Windows Defender. Firewalls are like inspection devices. What they are, they inspect the packets that come through them, and they act as filters. And so you can set it up as a way to filter traffic. That way, traffic that is considered to be insecure or maybe hostile to your business or your company, you can filter it out using a firewall. An IDS is an intrusion detection system, and what it does is it is programmed in a way to note something that potentially looks like an intrusion, and it uses what's called IDS signatures, and it works from a database, and it's also using information that's been gained over a period of time. And the IDS itself is designed to like catch or see these intrusions and to alert you to these potential intrusions. They're very sophisticated devices, a very special area in which to work in, but certainly a part of the landscape of IS security and controls. All of these devices that I mentioned, all of these ways to gain access, to log on, to log off, all of this can be audited too. And we can have auditing in the form of logs, which provides information for IT security administration to see what's going on, where there might be potential intrusion, where there might be potential vulnerability or weakness. And they use these auditing logs to to provide this information. And they have software that can parse it and go through it and find the information that they're looking for. So it's a fascinating area. IT security is big, broad. It's very competitive to get into. You need lots of experience to get into it, but once you're into it, it's really a fantastic area to work in. Again, thank you for listening, and hope to talk to you soon. That's